You ever stop and think about what really stops a multi-ton industrial press from coming down at the wrong time? I'll give you a hint. It's not just a simple switch. Nope. It's a hidden piece of tech, a real unsung hero of safety. So today, let's pull back the curtain and dive into the secrets of the Pilz safety relay. So to really get why this little box is so important, we have to start with the problem it was designed to solve. And believe it or not, it all comes down to the humble switch. I mean, really think about that for a second. You slam that big red button, the one thing that's supposed to be your foolproof safety net, and absolutely nothing happens. The switch itself, the very device meant to protect you, could have just failed. Maybe a wire came loose, maybe a contact inside got stuck. And that, right there, is the #1 rule of industrial safety. You simply cannot bet everything on a single component working perfectly every single time, not when people's lives are on the line. A simple switch just doesn't cut it. Okay, so if a simple switch isn't good enough, what is? Well, let's meet the solution to this high-stakes problem, the Pilz PNOZ X9P safety relay. I absolutely love this description because it's so true. This thing's entire purpose in life is to safely interrupt a circuit, and it does that by being incredibly skeptical. It basically assumes something, somewhere, is going to go wrong, and it's built from the ground up to deal with that. And look, this isn't just some marketing claim. This device is certified to the absolute highest international safety standards. Now, these ratings, Performance Level E and Safety Integrity Level 3, they're a huge deal. They are reserved for situations where a failure could be, well, catastrophic. This little box is trusted in some of the most dangerous places on the planet. So how in the world does it earn that incredible level of trust? Well, the secret is in its design philosophy, which is built on a few really clever ideas. The whole thing hangs on this one term, fail-safe. Now, that doesn't mean the device will never fail. Of course not. Everything can fail. It means that when it inevitably fails, it is guaranteed to fail in a safe way. The power will cut off. The machine will stop. No questions asked. And this is how it works inside. It's called the 3-contactor combination. Just think of it like this. K1 and K2 are 2 guards, and they both have to agree and turn their keys at the same time to open a gate. But then there's a third guard, K3, a supervisor, whose only job is to watch the first 2 and make sure they're both awake and doing their job right. It's a constant system of checks and balances, and it happens before every single operation. But that's the million-dollar question, isn't it? Because this is the nightmare scenario. This is the most common and dangerous way a normal relay fails. A tiny electrical arc can literally weld the metal contacts together, sticking the machine in the on position even when you're screaming at it to stop. And here is the genius, elegant solution. It's a mechanical trick. Inside the relay, the go contacts and the stop contacts are physically linked together. So if a go contact gets welded shut, that mechanical link physically prevents the stop contact from moving. The relay's internal brain sees this disagreement. It sees one part trying to go and the other trying to stop, and it instantly knows it has failed. It then refuses to restart, locking itself in a safe state forever. It detects its own failure. Brilliant. Okay, so we've got the internal theory down, but where do you actually find these paranoid guardians out in the real world? Well, you find them hooked up to pretty much every industrial safety device you can think of. They are the brains behind the e-stop button, the safety interlock on a machine guard, the light curtain that stops a robot if you get too close, and even those 2 hand controls that ensure an operator's hands are far away from the danger zone. Another really crucial part of the puzzle is how the machine restarts after a stop. You see, sometimes an automatic start is fine. The machine just gets going again once the area is clear. But if there's any chance a person is nearby, you absolutely must use manual start. That means a human has to physically walk over, check that everything is safe, and then deliberately press a reset button. It prevents the machine from just springing back to life unexpectedly. Now, because these devices have such a critical job, they also need to be able to tell you what's going on, and they need to be protected from the rough electrical world they operate in. And they communicate with a brilliantly simple tool, these little LED lights right on the front. A technician can just walk up to a control panel and immediately know what's wrong. Is the power light off? Okay, check the main voltage. Is the channel 1 light off? Well, the e-stop circuit must be open. It's an incredibly fast and effective way to troubleshoot. Right, let's get back to the main villain of our story. We touched on it before, but the undisputed #1 killer of any relay is the electrical arc. that tiny bolt of lightning that happens every time you switch a circuit. That's what melts metal and welds contacts together. And here's what's so fascinating. The contacts are getting attacked from two different directions at two different times. You have inductive loads, like motors, which create a massive voltage arc when you switch them off. But then you have capacitive loads, like power supplies, that create a huge current surge when you switch them on. The poor contacts are getting hammered from both sides. So, how do engineers protect our paranoid guardian? Well, they have a whole playbook. For heavy-duty motors, they use the safety relay to control a bigger, tougher switch called a contactor. They add fuses to handle overcurrent, and they install special circuits called snubbers that act like tiny electrical shock absorbers to soak up the energy from those arcs. It's all about defending the safety relay so it can do its job. And that really just brings us to the core idea behind all of this. This isn't about hoping things go right. It's about a healthy, productive kind of pessimism. It's about always asking, what's the absolute worst that could happen? And then building a system that can handle it. So the big takeaway here is that this little device, the PNOZ X9P, isn't just a box of wires and metal. It's a mindset. It represents decades of learning from mistakes and accidents, and it's the physical result of a philosophy that puts safety above everything else. And that kind of leaves me with a final thought for you. When you think about it, our world is just full of these invisible, paranoid guardians. From the anti-lock braking system in your car to the safety circuits in an elevator, what other ones can you think of that are quietly working in the background every day just to keep you safe?